All right, so let's test our understanding. The four types of energies that we're going to be talking about here are going to be gravitational potential energy, U sub G, spring potential energy, U sub S, kinetic energy, and I'm going to just use dE for dissipated energies. If a heavy block rests on a table, a person is going to lift the block up 1 meter and then drop the block onto the table, making a loud sound. When the person does positive work to lift the heavy block, force going in the same direction as displacement to get positive work, and we're lifting, so force up, then the blank of the block earth system increases. Well, what increases as our height increases? The gravitation potential energy. The block is dropped and the blank becomes blank in the block. Well, whenever something gets dropped, we know it has gravitation potential energy, and then it's going to start moving, so it has kinetic energy in the block. Finally, when the block lands, the kinetic energy of the block becomes dissipated energy. In this case, sound. Probably some heat too, but definitely more sound. Sound is going to be a lot more noticeable. Experiment 2. If a cart is initially at rest, so we know there's no kinetic energy, a person pushes the cart, causing the cart to speed up. The cart crashes into a wall, making a loud sound. The person does positive work in order to increase the cart's kinetic energy because they pushed the cart. So what kind of energy gets added to the cart? Kinetic energy, because speed is being added to the cart. When the cart crashes into the wall, the kinetic energy of the cart becomes dissipated energy. It'll be sound again. A person jumps off a bridge while attached to an elastic cord. Okay, so instantly my brain knows there's spring potential energy involved. Person falls, so I know there's gravitation potential energy involved until the cord begins to stretch. Then the cord brings the person to a stop, so I know they have no kinetic energy, before they land and hit the ground. Initially, before jumping off the bridge, the person-Earth system has gravitational potential energy. Right? Because before jumping off the bridge, they have to be at a height. As the person falls, the gravitational potential energy becomes kinetic energy. Once the cord begins to stretch, both the gravitational potential energy and kinetic energy become spring potential energy in the cord. Last one for this, a person pushes a box across a carpet. As the box slides across the carpet and the box become warmer. So we know there's friction involved, and friction is going to dissipate energy as thermal energy. The person is changing blank in their body. What kind of energy comes from their body? Ooh, it's not listed up there. So I'm going to have to spoil the surprise here. Chemical potential energy. Chemical potential. Know that it exists. There's no calculations that we have to do with it in this class, but it exists. It could be a source of energy. The likelihood that you're going to see this pop up on your AP exam is very, very, very low. But whenever you take in a calorie, whenever you eat something, a calorie is a unit for energy. So as you eat the calorie, you're gaining energy. That energy stays in your body as chemical potential energy. Then the muscles inside your body do work to transform that chemical potential energy out of your body into other forms of energy. A person changes chemical potential energy in their body into kinetic energy for the box, but friction is going to change kinetic energy of the box into dissipated energy. In this case, thermal for the box and the carpet. All right, and the last test your understanding for 5.1. Suppose a ball is dropped from a height h. If the ball is perfectly elastic, what would you expect the ball to do after bouncing? Explain what would happen in terms of energy transformations. If I see perfectly elastic, then I know, and if you don't know this yet, you'll know it definitely by the end of 6.2. No kinetic energy is lost. Remember from earlier units, that is a type of collision. Does not exist. It means no kinetic energy is lost, so that means all of the energy is conserved. So what would you expect the ball to do after bouncing? Well, let's draw a picture of this. If it goes down some height and no kinetic energy is lost, it is going to go back up to the same height after bouncing. So it's going to go back up to the same height, and what's it going to do? After that, it's going to fall, and then it's going to bounce and fall forever. There's no energy leaving. So this is what we would call perpetual motion. But perpetual motion doesn't exist in the world as we have found so far. Doesn't exist. Explain what would happen in terms of energy transformations. We're going to, let's do bar charts for this. Kinetic and gravitational potential. In the beginning, at the top, because it's being dropped, we have all of our energy is gravitational potential. As it's right here, halfway through, then we have some kinetic and we have some gravitational potential. Remember, these bar charts are moving. They're going up and down. On the bottom, at the very bottom, on the floor, then both units of energy are going to be kinetic energy, and we have no gravitational potential energy. And then it's going to go back up. I would say, to me, this is the easiest way to explain what's happening with whenever there's an energy transformation. It's intuitive. You don't have to remember how to do anything. You just have to remember that, okay, every time there's an energy transformation, I'm going to do this for certain parts. And just by looking at this, I can tell right here in the middle, maximum kinetic energy, that's going to happen just before I hit the ground, or just as I'm leaving the ground because there's no energy lost. So it's going to just continue this pattern for forever and ever and ever. Also, something interesting about this situation is that if this ball bounces and no energy is lost, no energy is dissipated, then that means there would be no sound as the ball collides with the floor. Crazy, right? Actual bouncy balls are not perfectly elastic, so what do? They bounce up to a lower height. And we can do the bar chart thing here again. This time we're going to have to add in a third one for that dissipated energy. So we have KUD, KUD, KUD. And then I would just go through and I would say, okay, at the beginning we have all gravitational potential energy here, and then here we have 1 and 1, they're both equal, no dissipated energy yet, and then at the point of the collision, we're going to have kinetic energy. Just after the collision, we're going to have some kinetic energy and some dissipated energy. That's how I would show it.